So hello everyone. As you see, I have chosen the topic slope and deflection as it is an important topic of strength of materials, and it's very difficult to remember all the formulas of slope and deflection for various cases. So I am going to discuss a shortcut method to remember the slope and deflection for various cases. Okay, so the first case is a cantilever in which a moment m is acting, and the second case is a cantilever in which a point load W acts. Third case is a cantilever in which uniformly distributed load W kilonewton per meter acts, and the fourth case is the cantilever in which uniformly varying load acts, in which at the fixed end it is maximum and at free end it is zero. Okay, so first I will discuss these four things, then we will proceed. Okay, so before going to calculate the slope and deflection, we need to remember the bending moment for these four cases. The first case bending moment will be m, then next case bending moment will be w into l, and the next case bending moment will be wl square upon 2. You need to remember this thing. Okay, and the next case bending moment will be w into l square divided by 6. Okay, so these are the bending moment. Now for calculating slope, there is a shortcut you need to remember. Okay, so for first case I will write ml by ei. Okay, and in the second case it is ml by 2 ei. Third case it is ml by 3 ei. In the fourth case it is ml by 4 ei. Okay, so just you have to put in place of m, you need to put the value of bending moment. Okay, so for this, in the first case it is bending moment is m, so after placing m we will get only ml by a. But in the second case, as you see, bending moment is w into l, so after applying in the value of m, w into l, we will get w l square upon 2 ei. Okay, similarly for the third case, if you will put wl square by 2 in m, in the place of m, you will get wl cube upon 6 ei. Similarly for the fourth case, if you will place wl square upon 6 in the place of m, you will get w into l cube divided by 24 ei. Okay, so these are the slope for the first four cases. Likewise, if you will calculate deflection for these four cases, it will be deflection will be slope into l by 2. For this, slope into 2l by 3, slope into 3l by 4, slope into 4l by 5. See how the pattern goes. It is l by 2, 2l by 3, 3l by 4, 4l by 5. Means how it is going, like here it is 1, here it is 2, numerator 1, denominator 2, then it changes to 2 to 3, 3 to 4, and 4 to 5. Okay, so what you have to do is you have to put the value of slope here. Okay, here slope is ml by a. After placing ml by a, we will get deflection is equals to ml square upon 2 ei. Likewise, here deflection, here slope is wl square upon 2a. After placing this value in here, means in the place of slope, you will get this 2 and this 2 will cancel, so you will get wl cube upon 3 ei. Likewise, if you will place wl cube by 6 ei in the place of slope, you will get a deflection of this 3 and this 6 will cancel, and here we will get 2 into 4 is 8, so we will get wl power 4 upon 8 ei. Likewise, if you place this wl cube by 24 ei here, this 4 and this 24 will cancel. As a result, here 6 into 5 30, so we will get wl power 4 by 30 ei. Okay, these are the basic four things you need to remember. First case is the cantilever with moment m. Second case is cantilever with point load w. Third case is cantilever with uniformly distributed load. Fourth case is cantilever with uniformly varying load, and at fixed end it is maximum and at free end it is minimum. Okay, so the fifth case is that you need to calculate the cantilever in which at fixed end it is 0 uniformly varying load, and at the fixed free end it is maximum. So for this, we what we can do is we can subtract the fourth case. Okay, subtract the third case from the fourth case. Means like this, third case is uniformly distributed load. We can draw this thing as this. Okay, it is uniformly distributed load. And in the fourth case, you see uniformly varying load, in which at the fixed end it is maximum and at the free end it is minimum. So this case, okay, after subtracting this we can get this figure. Okay, that means for getting this value of slope what we have to do, we have to subtract 3 minus 4, which means WL cube by 6 EI minus WL cube upon 24 EI. So after doing this, what we will get? We will get this 6 into 4, 24 LCM. Okay, so we will get WL cube divided by 8 EI. Okay, similarly for getting the value of deflection, again we can do the same thing. This 3 minus 4, which means WL power 4 by 8 EI minus WL power 4 by 30 EI. So what we will get? WL power 4 by 8 EI minus WL power 4 by 30 EI. You can solve it and you can get the value. Okay, I am skipping this value. You can solve it, you can get the value. Okay, next is a simply supported beam in which point load acts at the center. Okay, here I am not mentioning the length. You can get it that simply supported beam in which point load acts at the center. For this, bending moment will be WL by 4. Okay, it is again a simply supported beam in which uniformly distributed load W acts. For this, bending moment will be WL square by 8. Okay, for these two, remember how to find the value of slope. For this slope, just go for the fourth one. Fourth one was ML by 4 EI. So this will be again ML by 4 EI, and this value will be ML by 3 EI. Okay, just put the value of M, you will get WL square by 16 EI. Again put the value of M here, so you will get WL cube by 24 EI. Again I am discussing this thing, okay, in case you have not understood. Here look, first case is ML by EI, second is ML by 2 EI, third is ML by 3 EI, fourth is ML by 4 EI. Okay, for fifth we have to subtract 3 minus 4. But for this sixth case, how it is going? Look, ML by 4 EI, seventh ML by 3 EI. Okay, means these two values are decreasing. Okay, again for finding the value of deflection, this deflection values have no relation, you need to remember it. For this, deflection is equals to slope into L by 3, and this deflection is equals to slope into 5L by 16. Okay, so after placing this slope value here, slope value is WL cube by 16, WL square by 16 EI. After placing this, we will get WL cube by 48 EI. Similarly, after placing the value of slope, which is WL cube by 24 EI, here we will get 5 WL power 4 by 384 EI. Okay, last two cases are it is a fixed beam in which a point load W acts at the center. For this, I am not writing this moment factor because it is not going to ask moment. We just need to remember the slope and deflection. For this, slope is equals to 0. For this case also, slope is equals to 0. Okay, but deflection, it asks deflection. Okay, for deflection, just remember deflection is equals to 1 by 4 of simply supported beam. Again for deflection, 1 by 5 of simply supported beam. But which values? Look, simply supported beam, point load, deflection value is WL cube by 48 EI. We need to divide this value by 4, which means we will get around this value, okay, WL cube by 48 EI, we will get WL cube by 196 EI, and similarly this value L power 4 by 384 Yeah, thank you.